I'm sure it's out there. I just wasn't able to easily find it. So this is an interesting reaction. It's not just something that gives us delicious food. I'm going to tell you about this reaction here. We didn't get to talk about glycemic index of food. That's a really important topic I wish we had a chance to talk about. When I say glycemic index, that's a way of determining how rapidly a food raises your blood sugar, like how rapidly it spikes your blood sugar. That's an important concept because it relates to the insulin response that your pancreas has, number one, and the more chronically you elicit an extreme insulin response from the pancreas, the more likely you are to become insulin resistant and then develop diabetes, right? So that's the pathway to diabetes. So you want low glycemic index foods that keep your blood sugar, that don't spike your blood sugar rapidly. That's not the only problem with having high glycemic index foods, having chronically spiked blood sugar. Another one is just the fact that there's really high concentration of sugar in your blood. So this Maillard reaction that happens when we make it happen quickly between protein and sugar in the frying pan, it can happen at low temperatures too. It just takes a lot longer. So say you're diabetic, for example, and you have chronically elevated blood glucose, right? Really high blood glucose. Or maybe you're just a person that likes to eat a lot of candy, for example, food that has really high glycemic index, and you're like chronic. You do that into adulthood. You're going to expose the proteins in your body to chronically high levels of sugar, and as you do that, you run the risk of these kinds of Maillard reactions happening in your body. You're basically, cooking is not the right word, but you are going to be glycating, taking these glucose molecules. They are going to form Amadori products with the proteins in your body. Specifically, one of the major ones that is measured for this is hemoglobin, right? So these in the body, we call them these Amadori products. We call them advanced glycation end products, AGEs. They are a result of the Maillard reaction that's happening in your body with high blood glucose, and it happens between glucose and the protein L-lysine. And it contributes to a host of disease processes. So, for example, it has a lot of different complications associated with diabetes, not surprisingly, and macrovascular disease. So that can be like atherosclerosis. It can lead to Alzheimer's disease, cirrhosis of the liver. If you look at these are all microvascular diseases, so peripheral blood vessel diseases, uremia, meaning blood in the urine, arthritis, so there are proteins in the joint that get glycated and cause inflammation at the site of the joint, and broadly is associated with aging and other aspects of tissue degeneration. They're actually they've developed a diagnostic tool that can look at your blood and determine how much of these Amadori products are in the hemoglobin in your blood as a way of determining how well you've been controlling your blood sugar in diabetes or determining diabetic potential, right? Because it's a real measure of. So when you test blood sugar, that's just that moment that you're testing blood sugar. But when you look at these advanced glycation end products, it's sort of a picture of chronic exposure to sugar, right? It's looking at longer term levels of high blood sugar in your body. So just so that you understand that concept, because this diagnostic tool is likely to be one that's going to become much more commonly used And as you become adults and hopefully keep up with your annual physical and blood test and all that stuff, this is going to be a metric that you're going to begin to see, and it's important for you to understand what it is and how it relates to the Maillard reaction. Tasty bread, yeah. Yeah, so it's not related to eating Maillard products, right? Amidori products. It's not related to eating like the crust of a bread or like caramelized, or whatever. It's not that. It is directly related to what you eat in terms of how chronically do you eat foods that spike your blood sugar. That's right. So we didn't again, yeah. That's right. Yeah, the glucose is in your blood, the hemoglobin is your blood, and the lysine, the amino group on the lysine, is exposed, and the reducing end of the sugar, the aldose, the carbonyl on the end of the aldose in the glucose when it's open chain. It's just going to react with that. If you have a high enough concentration of sugar chronically, they're just there, and they'll run into one another, and they'll form these Amidori products. That's what's coming in between the second and the third picture. Oh, the water is a byproduct of that first reaction. Forming the aldosylamine. That's the first step in the Maillard reaction. If you look back at the steps that I showed you last time, you'll notice that water, it's a dehydration reaction forming the aldosylamine, and it gives off water. So I'm just including that so that you see that I didn't make atoms magically disappear. That water is part of that reaction, and it's a byproduct of that formation of the aldosylamine. Does that make sense? Yeah. That is exactly this reaction. So if you look at the that other slide and this one, the R prime here on the right, the left-hand side in the aldosylamine, that R prime is the hemoglobin molecule, and the R is the rest of the glucose molecule, and then it's the same rearrangement that shifts the double bond from the carbon and the nitrogen over to the carbon and the oxygen, because that oxygen is much more happy to be carrying that extra electron density. So if you look here, in this case, the double bond in the middle in the aldosylamine is between the carbon and the nitrogen, and then we have this Amidori rearrangement where that double bond shifts to the carbon and oxygen down the chain there. It's the exact same reaction. So I'm giving you an example of the Amidori rearrangement, not just in food, but how food relates to how it happens in your body. Does that make sense? Anything else? Good question. Thank you. Okay, so that's all I'm going to say about the Maillard reaction. The other sort of major category of cooking that can give us flavors besides the Maillard reaction. So Maillard reaction is between proteins and carbohydrates. The other major category is between carbohydrates and carbohydrates, and we call that caramelization. So caramelization is, again, a fairly sophisticated suite of chemical reactions that can happen, and I'm not going to blow your minds or mine by trying to get into them in much detail, but I'm going to point out a few important features of them. First of all, they can happen between any of these types of sugars, but they happen at different temperatures depending upon the sugar. All right. So, for example, fructose caramelizes at 110 degrees C, 230 degrees Fahrenheit, whereas lactose caramelizes at a significantly higher temperature, almost 400 degrees. To get caramel out of milk sugar, you have to almost double the temperature. And sucrose, a common, white table sugar, that happens at around 320 degrees, which then leads to a host of these compounds. So caramel is a complex mix. Yeah.
Sorry. For sucrose, do you have to bake it in an oven to make it caramelize, or how do you caramelize something? You do that in a microwave?
Microwave would not be easy to caramelize anything because, you wouldn't be able to do that very easily. So the way a microwave works is microwaves heat things by heating the water molecules in them. It uses microwave radiation, which is long wavelength radiation, low energy radiation that gets absorbed by water molecules, and the water molecules shift that energy from the microwave range into the IR range in terms of bond stretch and bond bending, right? So it makes the water molecules vibrate more, and so you're essentially heating the water in the thing that you're microwaving. So, for example, if you were to take purely lyophilized or dehydrated ice cream, astronaut ice cream, and put that in the microwave, you're not going to be able to heat it because there's no water in it, right? The question then becomes, can the sugar absorb enough of the energy from the microwave radiation to heat it to a temperature? So with water boils at 100 degrees C, right? And you can see here on this slide that the lowest temperature for caramelization is fructose at 110 degrees C. So you wouldn't be able to get that sugar up to the temperature of caramelization very easily. It would be very difficult to do that, right? I'm not going to say it's impossible because I've never tried it, but I think it would be difficult. Does that answer the question? Yeah. So sucrose can give rise to these categories of molecules. There's carmelan, carmelin, carmelin, caramelin. Carmelan, carmelin, caramelin. Those are the three tongue-twisting words. And they differ from one another in molecular weight. So carmelan and carmelin are explicit molecules, whereas caramelin, that really large one of C125, that C125 is an average empirical formula. It's like a host of all kinds of different chemicals that will be in there. And they're just combinations, molecular combinations, oxidation products of the sugars that are in there. So, for example, one of the ways, and this is kind of interesting in terms of how you cook. So, I have a friend who has a smoker, right? And he wanted to try smoking some salmon. And he took the salmon, he put it in the smoker, he took it out of the smoker, and it was fully cooked and tasted kind of smoky, and it was delicious, right? It was a delicious fish, but I didn't find it comparable to a fish that's been cooked under the broiler because since it was being smoked, the meat itself inside had all that flavor from the smoke that had infused and cooked the meat, but it was at a low temperature, right? You only get it up to about 200 degrees Fahrenheit, not even that, about 100 50 degrees Fahrenheit for it to be cooked, right? But at that temperature, you never get any of the Maillard products that are on the outside of the fish. So we decided to do an experiment where we made some glazes for it out of, we made a glaze out of it, two glazes, one out of sucrose, just table sugar, and another glaze out of fructose. We took some apple cider and we boiled it down and got apple cider syrup out of it and used that. And that's going to be really high in fructose, right? Fruit sugar, because it's apple cider syrup. And we marinated the meat and we put them both under the broiler on high for 3 minutes, and we got the Maillard reactions on the edges of the fish. We got caramelization to happen, and then we stuck it in the smoker. And so now we had the flavor inside the fish, but we had these other flavor molecules on the surface of the fish. And the way the fructose turned out compared to the sucrose was distinctly different because there was more caramelization using the fructose, the apple cider syrup, because it caramelizes at a lower temperature. We only put it under the broiler long enough to caramelize and create the Maillard reaction on the surface of the fish, but not cook the inside. We wanted the smoker to get the internal temperature of the fish up to where we wanted it and infuse that flavor into the fish. So the most successful of those was using the fructose glaze because we were doing a high temperature, very short stint under the broiler without trying to cook the fish all the way through. So knowing, my point in telling you this story about the fish is to tell you that by knowing the relative temperatures of caramelization in these different sugars, you can think about sort of engineering the recipe that you're trying to make, the kind of flavor profile that you're trying to achieve, given the cooking conditions that you're going to use for whatever it is that you're making. So, for example, if you're going to cook something over a long period of time at a higher temperature, then maybe it would be a smart thing to use either sucrose or maybe even some milk sugar, some lactose in there if you wanted to get a certain type of flavor profile along the surface of a food. Whereas fructose is going to be a much shorter time window to get those caramelization flavors. You won't need as an extreme a temperature to cook it. Questions about that? All right. So I'm gonna, because we're running out of time. I took a little longer there than I intended. I'm just going to talk about the phases of gastric secretion, how our stomach actually works, and how thoughts of food play into that. So we talked about, Jordan talked about the psychology of comfort food. I'm sad I didn't get to hear that talk. I was really interested to hear what he had to say, but I've talked to him at length. He lives in my building. But we're gonna talk a little bit about how this actually works in the stomach right now. So to begin with, I want you to think about this chunk of fish that I have taken some mustard seed and ground it up in the mortar and pestle. And I've added just a little bit of sizzled cumin seeds to that mustard, and I've mixed it in with some apple cider that I boiled down to a syrup on the back burner slowly. The whole kitchen smells like lovely bubbling apple cider. Yeah, mix in a little bit of garlic, just a hint of it on the underside of the flavor profile, and then I've taken this fish and I've soaked it in this marinade, right, with a little bit of lemon in there just for some brightness, an upper note of brightness to this marinade. And now I'm going to take this fish and I'm sticking it under the broiler and I'm heating it up, and we're starting to smell those lovely caramelization products. That note of garlic is roasting under the broiler, and it's filling the room with that smell. And the fructose is caramelizing. Oh, man. And now I'm putting it in the smoker. Meanwhile, I've got the hickory chips on the smoker, and there's that beautiful smell coming out of that thing, and the fish goes in there, right? And so after, 20 minutes in the smoker, 15, 20 minutes in the smoker, I take it out and I put it on the table. At this point, your brain, you see this lovely chunk of golden salmon covered in this beautiful glaze that just came off the smoker, and your stomach is rumbling, just rumbling, right? That is the first step in gastric secretion, the cephalic phase, how the brain gets into it. Okay, well, I'll finish off these three things, and then we'll pick up there. You can think about that chunk of salmon for the rest of the week.